Hello and welcome to second lecture in 12th chapter in our comprehensive course on AI, machine learning and data science. In previous lecture we have done about outlier detection and we found some techniques for outlier detection. Now here we want to do about what to do if outliers are found. Okay, so for that we have to learn something about outlier handling this thing. So basically just three methods are there. One method is removing. If outlier is due to incorrect data entry or measurement error, then simply remove. For example, age 356. Now clearly it is incorrect data entry. If you have the access to that person and ask him his actual age and correct it, that is the best thing. But if you do not have access to that person, then simply drop that data point. Okay. Then use percentile capping, which is called vincerizing. Now percentile capping is somewhat similar to this. Here the actual observations were these two green dots, and here these two green dots on the lower side also. But we kept the data such that the maximum possible value in this column, whose box plot is this, is Q3 third quartile point plus 1.5 times interquartile range. And similarly, we kept the minimum value to be Q1 minus 1.5 times interquartile range. Okay. Then all rest of the points, they are included and these points are not included. Maybe we kept them, so that means we convert them by reducing something from the larger value and by adding something into the smaller value so that they come in this range, or we exclude them. So this technique is called capping, or in more scientific language it is called vincerizing. Okay. Transformation. Now sometimes the data set is very highly skewed. Now if it is age data set, as I said 356 years age, that is not possible. But some similar data set for income of human beings, now there is more skew, even high skew on the right side compared to that, because in every economic system there are going to be some people who are extremely rich, like say Bill Gates and Elon Musk of the world and Mark Zuckerberg. So their income will fall if this x-axis shows income. Then rest of us will fall in some normal distribution. But those few ultra rich people, if they are also part of the sample, then their income may go somewhere here also. As my cursor, please follow that. So their income may go somewhere here also if this is the income axis there. Now here simply dropping them may not be advisable in all cases, because suppose income is itself your important parameter, and suppose you want to study say income inequality all over the world before and after the advent of capitalism and all that. So at that time you need those data. Then you can do one thing: this high skew database data set, you can convert some logarithmic transformation. So some kind of transformation is required to reduce the skew and to bring the data to a more manageable scale. Because we know this, that log n, its log is 1, 100, its log is 2. I'm talking about log to the base 10. 1000, its log is 3. So that means on the original scale, the observation simply goes on becoming 10 times. 10, then 10 times 10, that is 100, then 10 times 10, that is 1000, then 10 times 1000, that is 10,000, and so on. But on the logarithmic scale, same observation becomes just 1, 2, 3, 4. So that is pretty manageable. Okay. Now here we saw some techniques for outlier detection. One was deciding outlier based on how far away, how many standard deviation away they are from mean of the bell curve, or based on Z score, or based on median plus IQR on or median minus IQR as the acceptable range, or using a scatter plot, or using a histogram. But actually speaking, outlier handling techniques are much more sophisticated techniques are also there. But such outlier detection techniques are required. For example, here you can see some techniques, and these are not highly sophisticated. In fact, we often need to use them as in our career as a data scientist: supervised, semi-supervised, and unsupervised. But I had done a detailed discussion of that in this 7th chapter. If you remember, this actually graph also I have taken from there only. So you can see 7th chapter, and this is the same graph, right? So I'm not discussing them again. But Z-score is there here, interquartile range is there here. So which two we have discussed. Then KNN we have not discussed. Clustering is there. Now clustering is this kind of thing where you can divide the given data point into some distinct clusters. Each cluster has of same color data point. They have something common in them, or they are close to each other in important parameters, but far away from other color. Similarly, this green, they are close to each other in that some important parameter, but far away from both other colors. Okay. So once such clusters are formed, there will always be data point which will not fit in any of the cluster. Somewhere here a data point may be, or even inside cluster also there may be some points which are nearer to the boundary of the cluster. For example, these or these. Then you can detect them as an outlier and you can remove them. Okay. So clustering is also technique. Unsupervised techniques are there like K-means, DB scan, isolation, forest, autoencoder. We are going to see almost all of them as our course progresses. Now these are some research level techniques that in that also some will be repeated, but many of them, this classification is supervised, unsupervised, semi-supervised. That is almost similar to that. But in that simple data set, then go by this path, and complex data set go by this path. Again, we have done that discussion in 7th chapter. So you are requested to refer to that lecture. I'm not wasting the time here again. So many things will be repeated again and again because these things form the core of data science. And most important thing in data science is to get good quality data, because howsoever sophisticated algorithm, garbage in, garbage out, that adage always remains true. So if your data is not clean and in proper format, then even the most sophisticated algorithm is helpless. Okay, so this you will do, but here we continue with our discussion and let us create our standard method we are following, that we are, and whenever we want to study some concept, we are creating a synthetic data frame. So let us create a synthetic data frame like this, in which this is the dictionary, this is the key, so that becomes the column header, and this list is the possible value. Clearly 900 years age, that is outlier, so there is no need of even me writing this kind of comments. Okay, so 900 years of age is an outlier, that is very clear. So if you see, this visibly looks that it is outlier. Now how to detect and remove them? First, how to detect that this is the outlier? So for that I will find first Q1, then Q3, then Q3 minus Q1, that means IQR, interquartile range. Then I will find upper bound, that is Q3 plus IQR. Then I will find lower bound, that is Q1 minus IQR. And then I will detect the outliers. So first Q1. So Q1 is found by name of the column dot quantile, and in that quantile you write first quantile. Okay, quantile is the function which gives the quartile of the data set. So first quartile means 25% of the points should be below it, so 0.25. Okay, and similarly again take that same data set and take the third quartile. You want to find third quartile point, or that is the point 75% of the data points are below it, so quantile 0.75. Then find the difference between them, bigger minus smaller, and that is the interquartile range. So print your results. Now you can see that here the 25th quantile is percentile is here, and 75th percentile is 35.75. So that means my data set looks to be the data of pretty young people, because 75% of the observations in the data set, they are less than 35.75. Okay, and IQR, interquartile range, Q3 minus Q1, that is equal to this 35.75, Q3 minus this. Okay, and if I find it, it comes out to be 6.5. Now calculate the bounds. So lower bound will be Q1 minus 1.5 times IQR, and upper bound will be Q3 plus 1.5 times IQR. So find the bounds and then print them. So that is the acceptable limit. Okay, my data set is of young people, but acceptable limit is that up to 45.5 if the age is, I will not consider that as an outlier, and 19.5 up to that I will not consider that as an outlier. But less than 19.5, they are not even, I mean, adults, so we will consider them as children, and therefore teenagers, and therefore we will not include them. And similarly above 45.5 are also will not be included. So what are outliers in my data set? If I want to find, then I can take a conditional subset of my data set, and I can include only those points which are greater than or equal to lower bound. So greater than or equal to lower bound means this is lower bound, so they must be greater than or equal to lower bound means like this in this region, and less than or equal to upper bound, right? So in this region, these are the points which are the valid points or which are not outliers. Okay, so if I find DF age less than lower bound, now less than lower bound is okay, let me bring this box plot. Because I have to scroll a lot, so I don't want that. Okay, so here, okay, so below this, let me add a markdown cell and paste the then, sorry, I don't know. Yeah, here it must be marked down. Paste that image. Yes, for our ready reference, this is better. Okay, so now if this is the lowest possible allowable limit, less than these people we will consider teenagers, they are not part of my data set, and greater than these people we will not call them young enough. So that means this is the data set of young people. So anybody who is less than this 19.5, less than this lower whisker, and anybody who is greater than this, they will be treated as outliers. Like for example, these two green and these two green point. How to write that thing programmatically? Then df age greater than or equal to lower bound, and df age less than or equal to upper bound. That much you include. So include data points which satisfy this end condition. And whenever there is end operator, we know that condition on its left side also must be satisfied, and condition on its right side also must be satisfied. So those data points should be greater than this black colored line, and they should be less than this, that the other black colored line here on the right side. So those data points you find which obey this condition, and take a subset of original data frame from that data point. So that will become my cleaned data frame. You can see original data frame had 0 to 9 observation, and this was 900. Now this data frame has a 0 to 9 observation, but that 900 has been set to either, it is not removed actually, but I think no, it is removed. Then why the number of observations are not decreasing? That is what I want to see. Fifth observation was 900. Yeah, fifth observation is missing. So index is fine, but fifth observation is missing after fourth, directly 6. So that 900 age, which was clearly outlier, that row has been simply removed. Okay, so that is one method to remove the outlier, or one way of treating the outlier is simply removing it. Okay, now every time this will not work. For example, if you have some email addresses in one column, and you are asked that which email address is invalid, it is actually not even outlier in a sense. You can call that outlier because it is not part of the usual data. But suppose someone's email address is like abc slash or maybe hash gmail.com, then it is not the standard format. Standard format of email address should be like, for example, my email address is something at gmail.com, other person's email address would be something at outlook.com. So it has a standard format. So let us create one sample data frame, and these are some email values. So this is one, this is another, this is invalid underscore email.com. So here that at which must appear, that does not look to be present. Okay, this is another email ID, and we are creating standard way of the data creation. That is, email is one column which becomes the key of the dictionary, and this comma separated lists of email IDs that will become the values or the rows in email column. And similarly comments. So each person has made some comments, so you have to put them here. Okay, how many email IDs are there? 1, 2, 3, and 4. How many comments are there? 1, 2, 3, and 4. Right. So create the data frame first. Now creating. Now from this, someone says remove the email ID which is not valid. So that is also a kind of thing of like removing an outlier. Outlier means anomalous observation. So remove email ID which is not standard format. This looks to be standard format. This also looks to be standard format, and this also looks to be standard format. But about this I am not sure. In fact, for that you can create a regular expression like this. And in previous chapter I showed you that you should not be you should not panic that how can I remember such a long regular expression. First try to understand what this regular expression means. Then it means that this much portion says any alphabetical lowercase letter or any uppercase letter or any number 0 to 9 or underscore, then dot, and plus or minus, that is dot is full stop, and plus or minus, that much should be there. So anything out of this is allowed. This is the set of allowed characters. For example, here I can see that gen hyphen but hyphen is in the set of allowed characters, so it will satisfy that it is inside this pattern. Here I can see that John dot do. Now that is also, dot is also allowed character, so that means it will fall, the prefix before at, that will fall in this region. Okay, so this is the region before at. Now after at, what comes? The domain name. Okay, and the domain name can also be say gmail.com, hotmail.com, like that. Okay, so it can be any alphanumeric character. Okay, so A to Z small, or capital A to capital Z, or 0 to 9, or it can be sometimes even a hyphen also. Okay, and then this part, this is the escape character, so that takes care of this dot to be interpreted as dot. So that is like this dot. Okay, but if you don't write escape character, then there would be issues, because then Python will throw error. It does not know that it has to handle some reserved character. So dot is usually used for operators and everything, that we know. Then after dot, what can be that? Gmail.com, then com, org, then net, anything. So that is also an alphanumeric string. Okay, so that is alphanumeric string. Now this pattern you don't need to remember. Okay, because you can just search either from Google. We have done that in earlier chapter. If you see, I think we did it in maybe third, fourth chapter, that we can search from Google and find a valid email pattern, or we can ask AI assistant like ChatGPT or something that what is the valid email ID. For example, give me the regular expression for valid email ID in Python. As such, in Python is also not required because this part has nothing to do with Python. This is a language agnostic thing, but still, and it will generate the response. If I have connected it with my API, then it will generate the response. Currently, I think I'm using mobile data. That's why it is taking time. And maybe what Olama Wizard Coder, that is the selected model. That is why it is taking time. But it will generate, no problem. Import RE, and then this kind of regex will be generated. So I'm not even using my mobile data, or I'm not even using any paid model. That Wizard Coder is a free model, right? It is open source model, and it has given me that use this regular expression, right? So this is that kind of regular expression. In appearance, it may look slightly different than this, but it will also work in same manner. So this is a function which takes an email as argument, and we want to check whether that email is valid or not. So the name of the function is itself indicator is underscore valid underscore email, and it puts this pattern and uses re.match pattern email is not none. Okay, so that means it compares the given pattern, given email which you are passing here, whether it matches this pattern or not. So this match would be some kind of Boolean comparison, that whether these two are exactly equal or not. If the match occurs, that means if the email which I have passed can be generated by this general pattern, then I would get true, but otherwise I will get none. So this is just a function defined, but I have not called it. Now here I am in my data frame, email column is already there. I am adding a new column, valid email. Okay, so df valid email is equal to df email dot apply, and whenever we want to apply any operation on entire column, then we have to use apply. That we know, we have done map and apply in just a previous chapter, I think. So then apply, and after apply, either you can put some dictionary or something, or here you are putting some function. Okay, so we are putting our function. So on entire this column, this will be applied. This function will be applied. In other words, this each email will be tried, passed as an argument here to this function one by one, and it will be tried whether it matches this pattern or not. And if answer is correct, then it will give correct answer, and that email will be added in the df valid email column, a new column which will be created on the right side of this data frame, and then we will print that data frame. So if I write that, you can see that valid email is here coming out to be true. This is valid, these two are valid, and the bottom one is also valid, but this invalid underscore email.com, that is invalid because false is coming. The reason is it does not have that standard at, right? So it should have at. Also the one another reason is, even if suppose I add that at, still it will give invalid. No, I think then it will give valid because the underscore is also allowed character. So let me add that at, just checking that invalid email at xyz.com. Okay, and let us create our data frame once again. So invalid email at xyz.com, but now it will not be, no longer be invalid, I think. So yes, yeah, it shows that all are valid. Okay, so this just checks if email conforms with standard form or not. Okay, it does not check if email is actually existing email or not, because obviously there cannot be any such email, right? Okay, now extract date using regular expression, or in other words, remove invalid dates using regular expression. So here we again use a pattern like this, that and from this, these are the date column. Where is the date actually? Comments. Yeah, inside the comment only there are some date columns. One is invalid entry, but other comments have date column. And suppose I am asked that take this column as the argument, comments, but fetch only the dates on which the comments were made. That decides on which particular day users are more engaged with your website, and on which particular day the users are less engaged than with your website. So accordingly, you can do something to increase user engagement. So extract the date. Again, you don't have to bother about this pattern, but you can give this example to ChatGPT, and this example also, that give me a regular expression which has which gives correct or valid date for following examples, and then you can give these examples. So it will give you this regular expression. I can ask here also to that wizard coder, and it will give me these, or maybe equivalent, because sometimes the regular expression, same result can be achieved by a different regular expression. Now this function does what? It takes the comment from the comment column one by one, and it matches with this pattern. Again, re.search pattern and comment. So if the match perfectly occurs, that means that inside the comment some such date is found, then in that case you will say that true, otherwise it will get false. and then only match group we want. Okay, match group and with index 0, because I am here not interested in getting true false. I am only interested in what part of comment matches with date. So this part clearly does not match with date like thing. This part also does not match with date like thing. This part also does not match with date like thing. So obviously the other, they are matching with date like thing, right? So in that case, you can try this. And you can see that order dates have been successfully extracted and added as a new column, order date. Now, if there was no order date, for example, in this line, the name itself is invalid entry, so there is no order date, that nothing was extracted. So my regex is working. Okay. Now, nothing was extracted. That is, in a way, you can say that I am removing this entry. So these type of outliers are also there. So you should understand why this topic is being discussed with outlier detection, because one important technique of outlier detection and removal is use of regular expression. So outlier is a very broad term, and it is not only numbers which are unusual values, but it are also strings which are having unusual values. And then last part we will do this techniques for data normalization and standardization. But again, that part we have already done. Also, some more things we had done in the 7th chapter, that was deduplication. Okay, because the name of this 12th chapter is data cleaning. So data cleaning does not only include outlier detection, but it also included detecting duplicates and removing duplicates and non-imputation. So non-imputation is at the beginning of that 7th chapter. As we have already done all these things, we created a fake data set in which there were some non-values like this, and and even there were some invalid values. For example, the gender column should have only male and female, but there were some such value like non-binary and alien and unicorn and that. So we cleaned our data and we kept only those values which are uh, rational possible. Okay, then handling missing value, we said that either by mean. So this is the creation of data, mean for arithmetic column, or median for arithmetic column, numeric column, and mode. Mode is, I think, not shown here somewhere, but mode can be used for categorical column. So we discussed non-imputation, then we discussed outlier removal, then we discussed the deduplication. So I hope that you should remember this thing. If you are feeling that these things are coming from somewhere far behind in your memory, so that is okay, because you have to revise things at least 2-3 times. And the best way of revising things is not to revise the chapter, but to revise quickly, go through the lecture. You can run it at maybe 1.5 times, even 2 times if you require, and then tell ChatGPT to create a sample synthetic data frame and use that data frame to do all this. So in deduplication, a lot of discussion was done. Then single valued column also we had done discussion. Then normalizing and standardizing. Now, what I'm again saying is that means in the beginning of this chapter 12 only, I said that in this chapter there is nothing almost which was not discussed in earlier chapter. But just for the sake of completeness and convenience, we are putting them in a new chapter. Okay. So now we want to discuss this normalizing and standardizing with respect to this chapter 12. But again, it will be just a repetition that we can see here. So I will keep this chapter open, because whenever we require it, you should be able to refer it. Okay. Now, this is our next chapter's topic, normalization, techniques for data normalization and standardization.